Okay, students, now we know what is formula connecting resistance and resistivity. Resistivity is otherwise called as specific resistance. Then I'm rewriting this formula for resistivity. That is, if R is equal to rho L by A means we could write rho is equal to RA by L. Can I? I'm taking this row, keeping this row on this side and taking the other terms to the other side. Okay, therefore rho equal to RA by L. This is one important equation. If we have to define resistivity, if somebody is asking you what is exactly this resistivity and specific resistance, or is there any difference between resistivity and resistance, we'll say it like this. That is, we'll bring an if condition. If the length of wire is 1 meter and if the area of cross section is 1 meter square, can you say what will happen to this equation? Rho, then it will become R. This is the definition of resistivity. That is, resistivity is the resistance of the conducting wire with unit length and unit area of cross section. If we are having a conducting wire of unit length and unit area of cross section, the resistance of that conducting wire is equal to resistivity. Resistivity is not any resistance, it is specific resistance. What specific resistance? It is the resistance of that conducting wire with unit length and unit area of cross section. The resistance of a wire with unit length and unit area of cross section. Let's assume that this is a copper wire. What is the resistivity of this copper wire? It will be the resistance of this copper wire if we are taking it as unit length and unit area of cross section. That's why we are writing it as specific resistance or resistivity. What is the SI unit of resistivity? As we know, the SI unit of resistance is ohm. Area of cross sections SI unit is meter square. Length SI unit is meter. Therefore, meter square divided by meter. That means ohm meter. It is the SI unit of resistivity. Resistivity, it is also a scalar quantity. Therefore, now we know what is resistance. Resistance SI unit is ohm. It is a scalar quantity. Resistance depends on four factors. But resistivity, it will depend on two factors. Resistivity will depend on two factors. That is, one is temperature and another one is nature of material. Specific resistance or resistivity will depend on two factors, temperature and nature of material. It will not depend on length of the conductor and area of cross section of the conductor. That means if we are having a lengthy copper wire and a thin copper wire, both will have same resistivity, since resistivity will not depend upon length and area of cross section. So it is important to understand that resistivity is not depending upon the shape of the conductor. Resistivity is not depending on the shape of the conductor. If you are increasing the length or decreasing the length or increasing the area of cross section or decreasing the area of cross section, there is no change in the resistivity or specific resistance. But if you are changing the temperature and if you are changing the material, then resistivity will change. Okay, now let us look at the a problem which is regarding this resistivity and resistance. That is, let me give you an idea about that problem. We are having a conducting wire. This is our conducting wire. Its initial length, let's say it is L, and the initial cross sectional area is A. Let's say its resistance is R, resistivity is rho. Then we are applying a force on the two ends of the conductor. By applying a force like this, we are pulling it. If we are pulling this conductor, its length will increase. Its length is increased, so that assume that its length is increased to n times. That is, its length is increased to n times means the final length L dash, it is n times the initial length. Okay, it's done by pulling the conductor. Then let's assume that the area of cross section of this conductor is, or the second case is A dash, the resistance is R dash, and the resistivity is rho dash. Find out the ratio of resistance and the ratio of resistivity. Find out the ratio of resistance and the ratio of resistivity. That's our question. Let's perform it. For performing this, we know L dash is n times initial length. Then we could use our common sense to understand that if we are pulling the conductor, the volume will not change. The volume of the conductor will not change. Therefore, initial volume is equal to final volume. That is, volume is equal to volume dash. Volume is initial volume. Volume dash is final volume. And what's initial volume? Initial volume is initial area of cross section into length. Final volume will be final area of cross section into final length, where we know L dash is n times L. Therefore, we could write A dash into NL. And if you are looking at this equation, AL is equal to A dash NL, from which LL will get cancelled, and you could see A dash is equal to A by N. That is, area of cross section is decreased by n times. If length is increased by n times, area of cross section is decreased by n times. Then let's speak about resistance. The connection between resistance and resistivity is R is equal to rho L by A. This is the connection between resistance and resistivity. From our previous slide, we know resistivity will depend only on temperature and nature of material. Therefore, we are pulling the conductor, then nature of material will not change. And let's assume that the temperature is also not changing. Therefore, resistivity will not change. Resistivity will not change means I could clearly say rho equal to rho dash. Rho equal to rho dash. Then rho by rho dash is equal to 1. This is one answer. That is, we were asked to find out the ratio of resistivity and ratio of resistance. The ratio of resistivity is 1. Then let's continue over here. If R is equal to rho L by A means we could write R dash is equal to rho dash L dash by A dash, where we know rho dash is rho itself. Rho dash is rho itself. Therefore, rho L dash is NL. L dash is NL. Therefore, NL. A dash is A by N. A dash is A by N. Therefore, A by N. This by N will reach to the numerator. Therefore, N into N, N square rho L by A. Who is this rho L by A? Now, R dash is equal to rho N square rho L by A is the answer. Who's this rho L by A? Rho L by A is R. Therefore, I could write R dash, that is final resistance, is N square R. Clear? Then we could write R by R dash is equal to R by R dash is equal to 1 by n square. Okay, therefore this is the ratio of the resistance also. Okay, then if they are asking you what is the percentage of increase in resistance, what is the percentage of increase in resistance, if there is a question like that, then we could solve it by percentage of increase in resistance means it is actually delta R by R into 100. This is the percentage of increase in resistance. Therefore, delta R is change in resistance. That means it is final resistance minus initial resistance is R divided by R into 100. This is actually R dash minus R divided by R into 100. They are asking you R dash minus R divided by R into 100. Then it is, we could write it like this also. It is R dash by R minus 1 into 100. Clear? What's R dash by R? R by R dash is 1 by n square. Therefore, R dash by R is n square minus 1 into 100. This is the percentage of increase in resistance. That is delta R by R into 100. That is percentage of increase in resistance can be obtained by this particular formula. Remember all these formulas. Let's use these formulas into a case like this. That is, if we are having a numerical coming in a slightly different manner, I'll show you how to use it. That is, let us say if final length is 2 times initial length. Final length is 2 times initial length means final area of cross section will be A by 2. Clear? Then resistance or resistivity will not change. That is rho dash is equal to rho itself. Resistivity will not change. Then R dash final resistance will be, since it is n square R, we could use 4R. This is our final resistance. Then what is R dash by R? R dash by R, in this case it will be 4. Then delta R by R into 100, it will be n square minus 1 into 100, that is 4 minus 1 into 100, that is equal to 300 percentage. Okay, this is your answer. They could ask many questions like this. They could say if the length is 3 times, you could use this formula. Okay, therefore, this is the situation that we have to use in our pulling the conductor. Okay,